Okay, so let's take a look at the bonus from activity 4. So we want to replace all of these resistors with a single resistor between points A and B. So we need to start breaking the circuit down and looking at which parts of it can we condense or simplify into fewer resistors. So when I'm looking at this, the simplest leg of this circuit that I can see is this spot right here where all three resistors are in series. So if I included this 33 ohm resistor, I would have 3 resistors in series and 1 in parallel. So that would be more complicated. So let's just start with these 3 first. So I know that resistors in series add, so the total resistance of these 3 resistors is just the sum. So the resistor I'm going to replace these with is just 26 plus 21 plus 41 ohms, which is 88 ohms. So now I can redraw my resistor and replace these 3 resistors with a single resistor. So that will look like this. So now what's the smallest unit I have here? So now I have these 2 resistors are in parallel with only each other. So I'm going to simplify these 2. So in parallel, the inverses of resistances add. So the total inverse resistance is going to be equal to 1 over this resistance plus 1 over this resistance. And that will give a resistor of R equals 24 ohms. So now I'll do that. I'll replace this with this resistor again. So now my circuit looks like this. So these 2 have condensed down to one 24 ohm resistor. So now what do I have? Now I have I again have 3 resistors in series, which add. So the total resistance of these 3 resistors is just the sum of the resistances, which gives me a 45 ohm resistor that I can put in here. So now my circuit looks like this. It just has 2 resistors in parallel. So to find the total resistance, I need to add the inverses. So 1 over the total resistance is 1 over 36 plus 1 over 45, which means that my final resistor has a resistance of 20, and that circuit would just look like this. So this is completely equivalent to the circuit we started with.